Hello, everyone. How are you guys doing today? Cold? It is cold and rainy. Did the rain stop yet? No? Drizzling? Yeah. I don't know why, but I hate rainy days. It's bad. Annoying. And I have a fear like on rainy days, something bad might happen. I always have this feeling. And actually, it was true. My dad died on a rainy day. But I had the fear before even his death. And after his death, it's even more now. Okay, so we are done with chapter 5 and section 10.2. So today we are going to start chapter 6 and we are going to decide tomorrow after which section our exam should be. We are going to decide tomorrow our exam should be up to which section of chapter 6. Friday, tomorrow, 4.5. So if you haven't done 4.5 yet, tomorrow is the due date for 4.5 homework and quiz. Right, so their email address is fine. For my case, they send you an email. Yeah. So if you tell them to send me an email, they just send me the email. And it's even better. I don't have to send them. They will just send me the email verifying that you went there and you really learned your materials. So I need to have them to send you an email. No, did you get your email address, their email address on your paper? Yeah. Then it's fine. So the main purpose behind the test correction is that you're going to revisit those questions again in the final exam. So if you don't know how to do them, working with a tutor will actually help you to learn your materials. As long as you learn your materials, that's the main point. You get some extra points for learning the materials, which I failed to teach you. Okay. So before we start chapter 6, today we are going to do 2 questions from section 10.2. And in 10.2, there are a few questions left in our notes where you're supposed to factor or something. I'm going to skip those because they will not be in the exam. I'm talking about 10.2 factoring. In 10.2, there will be some questions you're going to see in your homework and quizzes, but those will not be in the exam, so I'm going to skip them for now. Yeah, they'll look bad. Any question before we start? Any comments, concerns, complaints? Okay, so do you remember what we do when we have question like the left page? So we have 6 and x to the negative 3. What do we do with them? Two. So we have to distribute to both of them, 6 and also negative 3. And then on the denominator, we have 2 and x squared. What do we do with that? But negative 2, yes. The denominator power is negative 2. So the denominator we distribute the power negative 2. Numerator has power positive 2. So we distribute the power positive 2. And then what do we do? Multiply the exponents. So you go to the exponent rules. Multiple exponents for one base, multiply them. So we have multiple exponents for the same base x. We're going to multiply them. So we have 6 squared. X to the how many powers on the numerator? If we multiply negative 3 and 2, negative 6. On the denominator, we have 2 to the negative 2. And if you multiply the 2 and negative 2, negative 4. So step 1, distribute. Step 2, multiply the powers if you have multiple powers. And now what is our step 3?
You have to, they have the same base, so you have to switch to get rid of the negative.
Anytime you see a negative power, switch the position for that so that the power becomes positive. So the 2 on the denominator has a negative 2 power. We have to bring it up 2 to the positive 2. Then we have x to the negative 4 on the denominator. We need to bring it up on the numerator to make it positive 4. And now on the numerator, we have negative 6 power. So we need to bring it down on the denominator to make it positive 6. Now the last thing we have is x with the square. Now, does it have any problem? What power 6 has? Sorry, not x, 6. What power 6 has? What's the power on the 6? Is it a negative power or is it a positive power? Which one? 6 on the numerator. Positive. So do you have any problem? So you're going to keep your 6 with the positive power. You only solve the problem, solve what has a problem. 6 doesn't have a problem, so it doesn't need any solution. We don't have to solve anything for 6 square. Besides the 6 square, everything else has problem, so switch them around. And when you switch them around, we notice something cool here.
You're not supposed to remove one base and put them together because they have the same base.
We are going to do it after we convert the negative into positive power. Like here, we have x to the positive 4 on the top, x to the positive 6 on the bottom. So you go to the exponent rule for division. In division, what do you do? How do you combine powers? In addition, we multiply them. In division, subtract. So what minus what? 4 minus 6 or 6 minus 4? 6 minus 4. Otherwise, you're going to get a negative sign. So you keep your x to the 6 on the denominator because this is bigger. And you subtract the 4 power from the numerator because it's smaller. Keep the position of the bigger power because it's big. It has more power. And switch the smaller ones. And then we do these two. What is 6 square? 36. And you're multiplying 2 square. What is 2 square? 4. And now you have to multiply manually. 36 times 4. 4 times 6 is 24. So 2 goes on the top as an addition. 4 comes down on the denominator, not denominator, on the bottom. And then we do 4 times 3, 12, plus that extra 2, 14. So the numerator, we have 144. And how about the denominator? Square. And we are done. So distribute, exponent rules, switch all the negative powers into positive by switching their position, and then more exponent rules. And one of these definitely will be in the final exam. And whatever question you're going to have in the final exam, you're definitely going to have them in the in-class exam. So expect to see this type of question next week. Was any step unclear to any of you? Was any step unclear to anyone? So every steps are clear. So how about the next one? I would like to try the next one. Taj.
You would multiply the exponents.
X to the 8.
Parentheses equal to.
Good. X to the 8 is bigger, so it's going to stay on its position. And we are going to subtract the 3 from the denominator. So we get x to the 5 on the numerator. So on the denominator, we have 8. And we are done. This is too easy, right? So this is not being that exam.
Get the same page. You have to like simplify it.
Anytime you have a multiplication or division with the same base, you must simplify. In multiplication, you add powers. In division, you subtract powers. And for multiple powers, you multiply them. Still 10.2. This is too easy. Too easy. So this will not be in the exam. The last page is in the exam.
Is there any chance it would be like the variables would be on the box, the same variables could be on the box?
If you have different variables, then you cannot combine them. And if you have same variable on the same position, let's say you have x to the 8 times x to the 3 over, let's say, 2 cubed. Since they're on the same position multiplying, so that time you add them, you get x to the 11 over 8. Same position means add the powers. Opposite position means subtract the powers. So probably in the exam, you're going to have the same positions, you're going to add them. Maybe. And maybe instead of having one variable, maybe you can have two variables, x and y. Which last part? Here. So we have x to the 8 divided by x cubed. So it's a division rule. So if you remember the rule, if we have x to the m divided by x to the n, what's the rule? Addition or subtraction, which one? M minus n based on the position. So if m is bigger, then it's m minus n on the numerator. But if n is bigger, then it will be 1 over n minus m on the denominator. So here, our denominator was bigger, so result is on the denominator. Here, numerator is bigger, so result is on the numerator. So you always have to divide. So you always have to subtract in division. But the position depends on which one is bigger. If the numerator is bigger, answer has to be on the top. If denominator is bigger, answer has to be on the denominator. Clear? With this, we are done and we are done refreshing our memory with 10.2. And now we are going to go to a very fun chapter, chapter 6. It's fun because all you have to do is factoring. Factor, factor, factor. Any question before we start? So instead of following section by section, I actually decided to do concept-wise. So we are going to start with 6.1, where we're going to talk about the basic factoring rules. How do you factor basic things? And then building upon all this knowledge, we are going to gradually go to higher level one by one. Maybe we have different sections, I'm not sure, but the materials, I arranged this chapter material-wise, from easiest to little by little to the hardest one. So the baby thing is, what is factor? Or what are the factors for anything? How do you find factors? Well, factors are the thing that you can divide anything by. For example, 3 is only divisible by 1 and divisible by 3. That means 3 has only two factors, 1 and 3. Also, if you multiply 1 and 3, you get 3. So the cool thing about factors is that if you multiply your factors, you're supposed to get the original thing back. If you don't, that means something is wrong. How do you decide factors? You see what numbers, by what number you can divide whatever you have. For example, 4. 4 you can divide by 1. 4 you can divide by 2. 4 you cannot divide by 3, but you can divide by 4. So 4 is divisible by 3 numbers. That means 4 has 3 factors, 1, 2, and 4. And among these 3 numbers, if you multiply 1 and 4, you get 4 back. If you multiply 2 twice, you get 4 back. So see, if you take the factors, multiply them, you're supposed to get whatever you started your journey with. Next is 16. Now 16 has so many factors. Why? Because we can divide 16 by so many things. 16 we can divide by 1. We can divide by 2. We cannot divide by 3, but we can divide by 4. We cannot divide by 5, 6, 7, but we can divide by 8, 9, 10, 11, 12, 13, 14, 15, 16. We cannot divide by anything else. And also we can divide 16 by 16. So 16 has 1, 2, 3, 4, 5 factors because there are 5 numbers by which you can divide our 16. Now among these 5 numbers, if you multiply 1 times 16, you get 16. If you multiply 2 times 8, you get 16. If you multiply 4 times 4, you get 16. You see, all the factors, if you multiply them, 2 of them, you get 16 back. So these are the factors for 16. Now, why do we care about the factor? Why do we care? Because factor is going to help us to factor anything. So this is saying, just like numbers, if you factor a polynomial and whatever you get, if you multiply them, you're supposed to get a polynomial back. If you don't get a polynomial back, that means the 2 factors you found is wrong. They're not right. Any questions so far? No? Huh? Okay. So here I put together all the rules how to find factors, but we're not going to read out everything. Instead, I'm going to read important parts. How do we find GCF of several numbers? Let's say we have number 12 and 20. I'm going to find what factors we get and what's the GCF. GCF means greatest common factor among all the factors that you have for all the numbers you're working with. So how do you find that GCF? You pick the biggest number of all the numbers given to you. And then you factor that biggest number. From those factors of the biggest number, you see which ones divide the rest of the numbers. And then pick the biggest one. For example, between 12 and 20, which one is bigger, 12 or 20? 20. So what are the factors for 20? 1, we can divide by 20. 2, we can divide 20. 4, we can divide. 5, we can divide. 10, we can divide. And 20, we can divide. So 20 has all these as its factor. 1, 2, 3, 4, 5, 6. 6 of them. 20 has 6 factors. Now, from all 6 factors, which of these divides 12? Can you divide 12 by 1? Yes. Can you divide 12 by 2? 12 by 4? 5? 10? 20? So there are 3 numbers you can divide. 1, 2, and 4. GCF is asking you, which one is the greatest one, the biggest one? So among 1, 2, and 4, which one is the biggest one? 4. So what's the GCF between 12 and 20? 4. The biggest number that divides both 12 and 20. That's called DCF, greatest common factor. And that's how we find common factor for any numbers. The next one is asking for the variable. Can you divide 20 by 6? Remember that 12 has 6, but we are not looking for 12. We look for 20 because 20 is the bigger one. Factor the bigger one. And then see which of these factors of the bigger one divides all the smaller ones. That's the trick. Now for variable, our life is easy. We don't need to do any math or anything. If you see same base with multiple powers, the smallest one is UGCF. Why? Let me show you why. If you observe y square, so how many y's do you have in y square? 2 of them, y times y. Now for y to the 4, how many y's do you have in the y to the 4? 4 of them. 1, 2, 3, 4. Now y to the 7, how many y's? 7 of them. 1, 2, 3, 4, 5, 6, 7. Common factor means you have to see the same thing in all 3. So how many y's you have in all 3? What is the greatest number? What is the biggest number of y you see in all 3 of them? 2 of them. The first one has 2 of them. Second one definitely has 2 of them. Third one definitely has 2 of them. So what is the greatest common factor between all 3, y4, y square, and y7? 2 of them, y square. So that's our answer here is y square. So for variables, even though you're looking for greatest, but actually we take the smallest power. Because the smallest power is visible to every other power or in every other power. So variable, smallest power. For numbers, biggest factor that divides all the numbers. Any question? Was any step unclear or confusing? Well, then test yourself. Find out the GCF in 8x, 6x squared, and 10x cubed. Basically, they are saying do the same thing twice, one for the number, one for the variable, and then at the end combine the results. So go ahead, figure out, and let me take that in this stuff. Andrea, Sheikh, Christian, Christina, Christopher, Danielle, Devlat, Dennis, Idaliz, Jared, Jay, Joshua, Justin, Caitlin, Kelly, Kyle, Lady, Muntaha, Nayari, Nicholas I, Nicholas S, RST, Rana, Ricardo, Taj, Mora, and Zichi. So far absent Nayari, Muntaha, Caitlin, Jared, and Andrea. 1, 2, 3, 4, 5. Nicholas, no fun. Any volunteer? Daniel. So what's the DCF of 8, 6, and 10? 2. What's the DCF of x, x squared, and x cubed? So what is our answer? 2x. That's the way to do it. Taj. Question? I think you're doing this. Okay. So next. Now comes the real factoring for this section, for this chapter. In this class, we are going to do 3 types of factoring. One is factoring 2 terms, factoring 4 terms, or factoring 3 terms. Every type, they have their individual way of factoring. If you have 2 terms, there are only 2 ways you can factor. Either you can factor out in DCF, or you have difference of perfect squares. These are the only 2 scenarios we have for 2 factors. If you have none of them, we cannot factor anything. Then 4 terms, it also has 2 scenarios. Either you can pull out a DCF, or you can use grouping method. What is grouping method? In grouping method, we group 2 terms into 2 factors, and then we use DCF twice. That's for grouping. We're going to learn this later. But this is an overview of what you're going to learn in chapter 6. And then we have 3 terms, the biggest portion of chapter 6. For 3 terms, there are 4 choices we have. Either you can factor out a DCF from all 3 terms, or since we are working with 3 terms, our main goal, bless you, our main goal is to work with quadratic ax squared plus bx plus c. These are our main goal to factor. Now, if you don't have any a, you have only x squared plus bx plus c, then our life is easy. We are going to factor directly, so it's called direct factoring method. But if you do have an a in front of x squared, and if that a is small, then we can use a method called AC method. So we have a squared plus bx plus c, and our a is a small number. And then we have another scenario. We have ax squared plus bx plus c. Both a and c, they are big numbers. If they are big numbers, we have to use trial and guess method. We can use AC method, no problem. But since the numbers are big, you'll get stuck in the AC method. So depending on what you have, we approach differently. If there is no x, or like easy, we direct factor to binomials. If we do have a, we look at which type of a we have, small or big. For small one, AC method. For big one, trial method. And that's what we're going to learn here. Any questions so far? Now let's start one by one. Factoring 2 terms with a GCF. We already know what is GCF, right? We already learned that at the beginning. Now, anytime you see a GCF, you're going to factor that out. Once you factor that out, what is left, how do you decide? Is by dividing both factor by the GCF. And then we put them together in a parenthesis. And the GCF on the outside of the parenthesis. That's the final answer. GCF outside and inside, both terms are divided by the GCF. Now let's do a few examples. Between 4 and 12, what is our GCF? 4. So we are going to factor out 4. And then this step we do mentally, but I'm going to show you here. We have our two terms. Whatever you factor out, you divide each term by that to see what is left after the factoring. So this will be our final answer. What is 40 divided by 4? 4 cancel out. So what's the answer here? T. Then you have plus sign. What is 12 divided by 4? 3. So we have plus 3, and this is the final result. So in reality, we never write this line. Never. Why? Because we do everything mentally. But if you do write them, the things become very easier to you to see what is left after you factor out anything. Did you ever see this before, this line? In any of the other classes? No, right? I'm also writing it for the first time with you guys. I never did that before, the second line. I realized people know what is GCF, but they don't know what is left after they pull out the GCF. So that's why I was thinking how to help you guys. And then I come up with, oh, this is actually the method. So why not make it visible instead of do it mentally? Okay. The next one, negative x plus 2y. Do you have any GCF here? No. So we don't have any GCF. That means we have something in common. When you have nothing in common, you have something in common, right? Everything is divisible by what? Definitely 1. So they have nothing in common, we agree, but we also know they both have 1 in common. We know we can divide both of them by 1, but also then we have a problem. Your polynomial is negative x plus 2y. So it starts with a negative sign. Think about real life. If you wake up in the morning, would you like to see something negative in front of you? Same thing is polynomial. If they start with negative, they hate that. So we want to take this negative out as a common factor so that our polynomial turns into positive. So anytime you have a negative something, factor that out. So we know we have 1 in common, but you're also factoring out negative because we don't like that. Now, once you know your common factor is negative 1, you have negative x plus 2y. So this mental part, you make it visible so that you can see after we factor out our negative, what is left in our polynomial. What is left in the first term? X, good. And what is left in the second term? Negative 2y. And that's all we are going to do when you have nothing in common. If we had only x plus 2y, we don't have to take any factor. Or if you want, you could only take out 1 as a common factor, you get the same thing. But because we have a negative polynomial to start with, so it factored out negative, as a result, we have a different thing from what is given to us. We just keep it. So the main purpose here is to show you anytime you factor out a negative, the sign will always change in your polynomial. So negative x turns into positive x, positive 2y turns into negative 2y. So sometimes you do have to factor out one is a common factor in the grouping method or in the SE method. So when you have nothing in common, you always have one in common. The next one, who would like to try the C? Y to the 8 plus y to the 4. Factor. Any volunteer? Christian.
So their greatest common factor would be y to the fourth, right?
Y to the 4. So you factor out y to the 4. And then let's make it visible. You divide by this. So what is left?
When you divide,
Mm-hmm.
yeah, so you get y to the fourth
Mm-hmm.
plus y.
They both are same thing.
Plus 0? I don't know.
What is 1 divided by 1?
1.
What is 2 divided by 2?
2. Okay,
What is 3 divided by 3?
So plus y.
No, what is y to the 4 divided by y to the 4?
Y to the first.
If you divide same thing on the top and bottom, you left with what?
Oh, just 1.
1.
Okay.
It's not y, it's 1. Y got cancelled out.
Okay.
Y with the 4 cancel out. And if you're not sure whether it's y or 1, no problem. Do the thing manually. Y to the 4 divided by y to the 4. It means we have y divided by y. So all the y cancel out. What is left? 1. Any question? So who is lost so far? No. Okay, so let me read your faces and then I'll pick the volunteer for D.
Mm-hmm.
And why? Because see, y to the 4 is DCF, we know. So you divide y to the 4 by y to the 8 by y to the 4. In division, we subtract the powers. So 8 minus 4 is 4. And y to the 4 divided by y to the 4. See here, that is also 4. Okay, so let me see.
Why is it just 1 and not just 1?
All the y's cancel out. How can you have a y left?
Oh, because I think that's 1.
What is anything not 0 to the power 0? So even if you do use exponent rule here, you get y to the 4 minus 4, which is y to the 0. And what is y to the 0? 1. You cannot put y to the 0. It doesn't, it looks weird. So you do have to put 1. You cannot leave the 0 power.
The 1 doesn't cancel out because if that's 1.
1 divided by 1 is 1. Canceling out means you're dividing. Okay, so last volunteer, Kyle. You said, so I was like, oh, let me pick him. This one is actually the easiest one. You look at the variables. What are the variables you have? X squared and X. So what's the GCF between X squared and X? X. So let me erase all these things. So you know you have to factor out X. In other words, to see what is left, you divide both of them mentally by X. So what is your answer? See, X minus 4. Not bad. Did he help you? Did he or? Did you learn that? That you have x minus 1. So remember, this step, we do it mentally. But make it visible, guys. If you do it visibly, then you can see what is happening. With 2 power minus 1 power, you left it x to the 1 power, but 1 is invisible. Here, x cancel out, you left it only 4. So you can see what is happening. You cancel the x, left it 4. And here, the exponent rules, 2 minus 1 gives you 1 power. Clear? So this is our first scenario. 2 terms with GCF in common. What is our next scenario? Perfect squares. If you have difference of perfect squares, means the 2 things you have, they are perfect. Either they are perfect numbers or they are perfect power. Perfect power means they are multiples of 4, multiples of 2. So 2, 4, 6, 8, in other words, even numbers. If you have even power and perfect square numbers, we call them difference of perfect squares. So for difference of perfect squares, our life is easy. We get the 2 factors which are called conjugates. How do you find those conjugates? It is the square root of the first term and square root of the second term. The result, you add them and subtract them. So this is what I said here. Square root of the first term plus the square root of the second term, that's the factor 1. Then square root of the first term minus the square root of the second term, that's your 2 factors, second factor. And that's how you have 2 factors for your difference of perfect squares. For example, x squared minus 25. So if you take the square root of x squared, what is square root of x squared? X. And what is square root of 25? 5. So you found your 2 main partners or 2 main individuals for your conjugates. So what are the conjugates you have? Personally, I like to start with my plus. The position doesn't matter. One of them is plus, one of them is minus. But my personal preference, I want to start with something positive. And that's what you're going to do. Anytime you see perfect numbers, even powers, perfect numbers and even powers, you have times of product of 2 conjugates. Who would like to try the next one? Justin. So square root of x squared is x and square root of y squared is y. So you have x plus y and x minus y. Again, these things are mental things. We actually never write them out. But if you do write them out, you can see what are the 2 things you have to add and subtract. Question? That's why this method is called difference of perfect squares. This one works only when you have a minus sign between them. If you have a plus sign between them, there is no factoring rule. You cannot factor them. Plus or sum of perfect squares, those are bad. We cannot go any further with them. But difference of perfect squares, we can keep going further until we stop somewhere. Who would like to try C? X squared minus 1. Christian.
Wait, question. So you would do what Would it be odd for the,
What is square root of x squared?
that fact,
And what is square root of 1?
just one,
So what are the two factors you have?
x plus 1, x minus 1? I thought you would take
No, minus is the rule. You never touch the minus. Minus is the rule difference. And you only look at the two terms. Ramonsa, how would you like to try D? What is square root of y squared? Y. And what is square root of 4 over 9? 2 and 3. So what are the two factors you have? 2 over 3. Y minus 2 over 3. See, fraction look bad. But how simple things are. Take the square root visibly instead of mentally. Now, building upon this, we have little bit advanced level of difference of perfect squares.
What is that? What is the second one?
Square root of 4 over 9.
On the first one.
Square root of x is x and square root of 1 is 1. So it's x plus 1 and x minus 1. Which one are you talking about? Which one? Or this one? Yeah. Studies they have it. My 2 is, it looks like a bird. I know it's weird. But it's my habit. Okay, so building upon that knowledge, we have a little bit advanced where we have a GCF that we can factor out.
So the GCF of 36, 8.
So GCF of 36 and 9.
And then, so it'd be,
3 is a common factor, but not GCF.
oh, 9.
9. 3 can divide definitely, but these are the biggest one. They're looking for the biggest one. The biggest one is 9. So we factor out the 9. And we do the same thing what we did before. The mental math we are going to show using our pen or pencil. We divide both of them by 9. So what do we get?
You get 4.
4a square minus
B squared.
b square. So we have a DCF and we still have what? Difference of perfect squares. That means you have to factor more. So we do the same thing again. We take the square root of 4 and square root of a square. What is square root of 4? And what is square root of a square? A. And what is square root of b square? B. So if you factor this difference of perfect squares, what two factors we get? Perfect. And we have a GCF, you cannot forget, at the front, in the front. So it's same difference of perfect squares, but 2 steps, because you have a GCF. Anytime your polynomial has a GCF, your first step always should be take it out.
You have to write them GCF separately.
No, you can do everything mentally.
But we're not writing it down before it or something, right?
As long as you get it correct. So what, from here, I want to see this line and then this one. These 3 things, go ahead. So definitely write this down to show me GCF and then show me the final answer. These are the 2 things you definitely have to write. It is minus b. What's wrong with me? Thank you. It's minus b. Who is ready for the next one? Someone who did not answer yet. Sheikh. DTF is 2, so you factor out 2. So what do you get? Yeah, but when you factor out 2, you have 8x squared minus 2, right? So factoring out means you're dividing them by 2. So once you factor out, what do you get? What is remain in your parentheses? 4x squared minus 1. And now this is difference of perfect squares. So what is square root of 4 square root of x squared? X squared x. And what is square root of 1? So what two factors you get from your difference of perfect squares? What do you get from here? 2. So 2x and then plus 1. The next one? 2x minus 1. And you cannot forget about your GCF. What is your GCF? 2. So this is the final answer. GCF and then difference of perfect squares. Is anybody lost yet? Not yet. Then we are going to go a little bit more advanced level. It's a little bit more because it's not 2 power anymore. It's 4 power. But it still doesn't matter. Remember I said anytime you have a minus sign and then any even power, they call difference of perfect squares. 4 is a perfect square number. So anytime we have 4, we are going to do the difference of perfect square, but twice. So this is an example of double difference of perfect squares. You will see. So we do the same thing as we did before. We take the square root of x to the 4 and square root of y to the 4. What is square root of x to the 4? Huh? X to the second. What is square root of y to the 4? Y squared. So what are the two factors we get? Mm-hmm. Mm-hmm. Mm-hmm.
But can we set the radical to 4?
What do you mean by radical to 4?
We do the radical, like let's say for the one with 16, right? We would do radical 16x to the 4th and then put a 4.
Okay. So if you have x to the 16 or only 16, what you're talking about?
I'm saying like you see 16x to the 4, right? So we would take the square of that, but set the radical to 4. So like the 4 would be like.
But there is no rule for difference of 4th power. We have difference of perfect square. Square means 2 power. So all these rules apply only when you have 2 powers, not 4 powers. That's why this 4 power, we need to break it down into 2 powers. Difference of perfect square. Now here are deals. We have perfect squares, x squared and y squared. Both of them are perfect. But what sign we have in the middle? Sum. So this sum of perfect square. Do you have any rule for sum of perfect square? Did I ever tell you this is the rule for sum of perfect squares? Sum doesn't have any rule. Sum is already high. Sum is much more. But what do you see here? Difference of perfect square. So can you factor this more? Anytime you see difference of perfect squares, you can always factor them. So in this difference of perfect square, square root of the first term is x squared. What is square root of x squared? X. And the second term is y squared. So what is square root of y squared? Y. So what two factors we get from the difference of perfect squares?
X minus X plus Y,
X plus y, x minus y. But we cannot forget about what? We don't have GCF here. We have sum of perfect squares. We cannot forget this. 3. So we don't get 4, we get 3 factors. So you have to keep factoring until we cannot factor anymore. So if you have 6 power, you stop in second step. If you have 8 power, you have to keep factoring. Because 8 is divisible by 4, 2 is 4, 4 is divisible by 2 is 2. So you keep factoring until the power is 1. Question. Now do you feel lost? Okay, who said yes? Now if you said yes, I'll help you. That's what I'm asking you. Then help you with the next one. Now you see clearly the difference, right?
Wait, can I ask a question? Why do you leave out the X to the second plus Y? I mean,
Because
why-
there is no rule for plus.
I mean, not plus, the minus. You left out the X to the second minus Y to the second. Is that because that's the one you factor? Okay.
Because you have difference of perfect squares.
Okay.
Anytime you see difference in the perfect squares, you can factor.
And then you just bring down the X to the square plus Y. Plus Y.
So Kyle, is 16 a perfect square? So what is square root of 16? 4. Is x to the 4 a perfect square? What is square root of x to the 4? X2. Is 81 a perfect square? What is square root of 81? 9. So that means what two factors we get? 4. This is 4, right? 4x squared plus 9. 4x squared minus 9. Now is 4 a perfect square? Is 9 a perfect square? 9 is a perfect square. 3 square is 9. Justin?
So why on the first problem, did you have to do square y squared? Plus y. Why can't we put x squared plus y squared and then try to see x squared minus y?
We did that here. X squared plus y squared and then x squared minus y squared. We did that.
Yeah, so we can just leave it like that.
We cannot. Anytime something is factorable, you must factor. So we factored once and then we realized, oh, this is factorable. So we factor it more. Now what do you observe here? 4 is a perfect square, 9 is a perfect square, x squared is a perfect square, and you have a minus between them. So the second one is more factorable because we have difference of perfect squares. So it is the square root of 4 square root of x squared. 2x. What is square root of 9? 3. So what two factors we get from the second term?
2x plus 3
Mhm.
2x minus 3.
Perfect. You cannot forget about the sum. It's a third wheeler. We have to bring it. 4x squared plus 9. So at the end, we have 3 factors from the 4th degree. So in the exam, I'm going to give you sum of perfect squares and tell you to factor. What you're going to tell me? Not factorable. Sum of perfect square is not factorable. We do not have any factors. And whatever we cannot factor, we call them prime polynomial. Prime polynomial. means they cannot factor. Cannot be factored. Example, x squared plus y squared. It's sum of different square. We cannot factor. 4th degree or 6th degree or any even degree. Sum of perfect squares we cannot factor. So that's why in the last two examples, we could not factor x squared plus y squared or x to the 4x squared plus 9. We could not factor them because this is sum of perfect squares. That's why always remember the rule is difference of perfect squares. You see, you have a minus sign between two perfect square things. Any question? No, these are only for factoring. In factor, you always multiply. You never divide. I'm going to say factor and then give you a bunch of polynomials. So if you see plus, you're going to say not factorable. And you get 1 point. Easy 1 point. Factor completely. So if you factor halfway, you're going to lose points. Factor completely. I see. Huh? Prime polynomial means this polynomial you cannot factor. So when you have a plus sign between perfect square, we call it prime polynomial. Or any polynomial that is not factorable, we call them prime polynomial. Prime means not factorable. Like prime number. 3 is not factorable besides 1. Huh?
I was going to say it's like prime numbers.
Right, like prime number 3, 5, 2, 3, 5. They're prime numbers. Why? Because you cannot factor them besides 1. So these are all the scenarios for two terms. Any question on any of these two term scenarios? So we learn GCF, we learn perfect squares. Then what happens when you have a GCF in the perfect squares? And what happens when you have 4th degree in the perfect squares? We learn 4 scenarios with the perfect squares. And now comes the fourth term. Fourth term is easy because you have only 2 methods, either GCF or grouping, or both. So question number 1. Do you see any GCF in this polynomial? What do you notice? 2. So you factor out your GCF first. And if you do that division mentally, from 2x, you divide it by 2. What is left in the first term? 1x. Then you have minus 2. You have minus 1. Then you have minus 2x cubed. Minus x cubed. X squared. So we did the factoring mentally. But if you want, you can make it visibly by dividing each one of them by 2. So you can see what is left after factoring. And now still how many terms we have? 1, 2, 3, 4. So that means now we have to go to grouping methods. So we're going to group them. In one group, 2 terms. In another group, another 2 terms. And then you're going to do the GCF again. So in the first group, group number 1, what is your GCF? Good job. 1. When you have nothing, you always have 1. So this time, does sign change or anything? No, right? Because we didn't take out negative 1. We only took 1. So you still have your x and you still have your minus 1. And if you observe the second group, how your second group started with? Minus. So what do you have to do? Factor out your minus. Anytime you start with minus, you always have to take it out. And now what's the GCF between x cubed and x squared? Only x? GCF squared. Now let's do the math visibly. We have x cubed and x squared. We factored out minus x squared. So what is left in the group? X cubed minus x squared is x. And then plus and minus 1. But we still have our two groups. So this was our group number 1, and this was our group number 2. And we still have them. We didn't do anything, right? Besides factoring each group. Now, if you look at both groups, do you see anything in common? What do you see in common?
X minus 1.
X minus 1. So this time we factor out x minus 1. That's why this chapter is called factoring and solving.
Just never ends.
It will end now. So you see x minus 1 in both groups. So remember, factoring means dividing. So if you divide this one by x minus 1, what is left in the first group? 1. And if you divide this by x minus 1, what is left? Minus x squared. So from 4 terms, we get 2 factors. But what we cannot forget about? GCF. Good job. We pulled a GCF out, so we have to keep bringing it down. And now we are finally done.
Can you explain the last part? Right, so I see that you divided them both by x minus 1 because that's the equation that's in them. And
that's because we factor out x minus 1.
Okay, you factor out x minus 1. Okay, and
so factoring means you're dividing the remaining things. So you have 1 times x minus 1. You factor out x minus 1, so they cancel out, you left it 1.
And now 1 goes there?
As a new factor.
Okay.
Now in this group, you have negative x squared x minus 1, but you factored the x minus 1 out. So you
And
left
then
it
you just bring
negative
down
x
the x
squared.
minus 2. Okay.
So
Wait, so how did the green x minus 1 get there?
that's you factor out. So start from the beginning. We have 4 terms, so we group them. Group 1, group 2. In group 1, we have 1 common, so we left it x minus 1. In group 2, we have negative x squared common, so we left it x minus 1. Now, if you look at both groups, do you see same thing in both groups? X minus 1. So you factor that out.
And then you just bring it down. Okay.
So from the first group, you factored that out, you left it 1. In the second group, you factored that out, you left it minus x squared.
And that's how you got the second group.
And that's how we group. Exactly. Are you done? Thank you. Are you done?
So why'd you put the box?
Exactly. I thought you're done until somebody. Oh man. Normally we are done. Okay, normally we'll be done. What do you see here? Difference of perfect squares.
I can't do this, man. It's too much.
True, man. So we have square root of 1. What is square root of 1? And what is square root of x squared? So which effect we get from here? 1 plus x, 1 minus x. And we just bring the other 2 down. 2 times x minus 1. And now you're finally done. Finally. Shortcut. If you do everything mentally, then it's shortcut. But no.
It's like one, right?
One.
Please let it be one.
They will be that.
Yeah. Our exam is Tuesday, right?
Yes.
Tuesday. Oh, it doesn't work. It should be Tuesday, right? You want to change it to Thursday? Of course I do.
Thursday.
Will you study? Okay, then you'll do it Thursday. Make sure study. Study. So tomorrow, if you have any questions, I can go over with those. So tomorrow we are going to do one more 4, and then we are going to do tomorrow, not today. No, 2 more 4, and then we're going to go to 3. 3 is easier. Not homework. So we started 6.1. So start practicing 6.1.
Right? No, because when I saw the 1 minus x squared, I was thinking you can still factor it, but because it was rotated, I didn't know if it would still apply, so I didn't.
Which one are you talking about?
You know, on the last one, 1 minus x squared, I'm like, wait, that's a difference of a perfect square, but
Yeah, but it doesn't matter which position, in which position they have, as long as you have difference in the between and the perfect squares, you just take them. Or if you have a reflection, please give me a reflection. Thank you.
what are the rules for 3 factors? It's AC and then what else?
First one is AC if A is visible and small number. And then if A is visible but big number, then trial method.
But you can still do AC method.
Yeah.
Because I've always just done AC method. But when there isn't when A doesn't have a,
When there is no A, you factor directly.
just like we've been doing.
No, yeah, we have a new rule for.
No rule.
It's not bad. The new rule is not be bad.
It's gonna be with password.
We are going to decide tomorrow.
Oh, okay.
I received your email. I'm just a little confused. You mentioned I have to go to the third floor to get paper.
Yeah, they'll
I
give
sent
you.
you the accommodation.
Yeah, but that's for me to know about you.
Oh, you want?
You know,
the
to get
exam?
exam.
Yeah, I know about that. You want that paper?
Yeah.
So I gotta let them know today. The 7. Okay, I gotta let them know them today. I just send that to you.
No, you're going to. I think you're going to. They'll give you a copy.
Yeah.
And then-
to you, you sign it, and then I email it to them with you attached, so they know they can sign.
Okay.
Is that okay? And then
Or you can bring the physical copy and then just sign the physical copy.
And then for the first
The exam will be not Tuesday, Thursday.
Then for the first exam that I missed, is there any way I can make
The blank exam is on Whitespace. Print that out and then go to the tutoring center. With it, work with the tutor. Fill the entire exam, you get 10 points.
Okay.
And then if you take the reflection, which I'm going to do now, you get 3 points.
Cool.
So fill out this reflection.
I
And
know
then,
it's a big thing, that's fine.
yeah, so you do based on your experience. Like if you had taken the exam,
Okay.
then what would happen?
Okay. Thank you, Professor.
Yeah. And I marked your exam, so I'm gonna change. So we just 10, then that must be 12, right? 12 times 2.